Hi, my name is Bill Bailey. I've been a hydronic system manager here at TEC for 20 years and been in the business for 35. Today we're going to talk about the 5 major components of a typical hydronic system. Terminal units, boilers, expansion system, piping, and circulation. The first major component of a hydronic heating system is a terminal unit. And what's a terminal unit? Well, a terminal unit is any device or system that will take the hot water that we're delivering from the boiler and provide heat to the room or building or whatever we're dealing with. We're going to talk about 4 types today, but there's multiple other options out there in the system that do the same thing. So basically the first one, most common to everybody, is probably a radiator. Big old cast iron radiator, weighs whatever, 60, 70, 100 pounds. We circulate warm water from our boiler into that radiator. That radiator warms up, then heats the air in the room and also radiates heat out to you. The second component would be baseboard, a little more modern version that basically is a little cleaner, smaller, more compact, that basically has fin tube inside of it. This is a piece of fin tube. So we circulate our warm water from our boiler inside the copper tubing. These fins get heated up. As these fins heat up, they create a convective airflow that provides and warms up the air into the room to heat you. The third system is basically a radiant floor system. This is probably the oldest. It's gone through some problems and hiccups back in the 50s and 60s, but nowadays, with all the new PEX tubing, it's very, very popular nowadays. And in this application, we put the tube into the system, pump water through this tubing, and in this scenario here, we're actually heating up a concrete floor. There's other ways of doing this, but this is the most common. We heat up that concrete, and actually that concrete becomes our radiator. So now you're walking on concrete in bare feet, and it feels nice and warm, and that's heating up your room. The fourth type is basically a fan coil unit, and that is basically taking the fin itself, like a radiator in your car, and filling it with water, circulating that water through that coil or that radiator. With a fan behind it, we blow that hot air into your room through the ductwork. The second major component in a hydronic heating system is the boiler. Now there's all different types of boilers, all different varying ages. I'm going to give you a quick look at the 3 major types we're dealing with nowadays. Okay. The first one is the typical cast iron boiler. Got a couple burners in the bottom, cast iron block in the middle, normally vented up a regular chimney or flue in the 80% efficient range. Nowadays, we are going to more high efficiency stuff or equipment. Over here is a typical high efficiency fire tube type boiler. By fire tube, what it means is basically the tube, there's tubes in the boiler and the fire is in the actual tubes. If you were to open this boiler up, you'd see basically like a 5-gallon bucket with a bunch of straws. The straws are where the fire goes, so it's called a fire tube boiler. Next version over here is basically a water tube boiler. And in this unit, this is the actual heat exchanger. A coil like this, water goes in, circulates around, goes out, it's hot water on the outside. My flame is right in here, so I'm transferring my heat through these coils into the water, into my system. We do this on small residential units, and then by adding more coils, we can actually make commercial units. The last type of boiler you'll probably see out there is more related to this guy, and basically that was a power burner type boiler. This would be in more your like commercial buildings, that kind of stuff, where basically you had a cast iron boiler with a very large flame or power flame that's basically blown into the boiler itself. The third major component of a typical hydronic heating system is the expansion system. Expansion system consists of 3 parts or pieces. 1 is the air eliminator, 2 is the expansion tank, and 3 is the backflow preventer / reducing valve. Air eliminator and expansion tank, we have 2 videos that go much more in depth about both products. The reducing valve system is basically 2 components. 1 being a backflow preventer and 2 being a pressure reducing valve. The backflow preventer is basically there to take water into the system and not let it go back into your domestic hot water system. So basically it's a one-way valve. Our fresh water can only come in here. It can never go back into your drinking and potable water. That's the backflow preventer. There's different models of this based on the code requirements in your local area. The second piece to this is basically a pressure reducing valve, or a PRV. There's all different versions of them. This is one. Here's a second one. Here's a third one. Okay? They all have different quality parts and features to them as far as fill, backflow, and everything else. But basically they all do the same thing, all three of these, which is take this water, which coming from your city or your well might be 30, 40, 60 psi. If we let that water directly into our boiler system that's running at 12 psi with a 30-pound relief valve on the boiler, and I've got 40 pounds over here and no valve here, that water's going to go right out through my relief valve, and we don't want that. So we need a PRV, or pressure reducing valve, to take this high pressure water, reduce it down to about 12 to 15 pounds, which is what a typical hydronic heating system residentially and light commercially runs at. Major components of any hydronic heating system is the piping and the circulation. The piping, pretty obvious. We are connecting all these components together so the water has somewhere to flow to get the heat that we generated in the boiler over to our terminal units to make everything comfortable. So that's pretty straightforward. The circulator, which everybody calls a pump, which is incorrect, because if you think about a pump, that's sort of like your sump pit, or that is your sump pit in your basement. You're taking water from a low point, raising it up, and throwing it out of the house. So that is a pump. A circulator in a hydronic system, or any system, is circulating water around the system to overcome the friction loss of the pipe itself, of all the components we have within the system. So the circulator is moving the water around the system, overcoming all the friction that we've created within the piping system itself. So the two are definitely related to each other. Examples here, here's some small circulators that would typically be used in a residential application, even a light commercial application. Circulators becoming much more powerful in overcoming resistance, so we are able to reduce the size and the electrical draw that these units need nowadays. We even have circulators now that are variable speed in this small market range, because the cost of that technology has come down drastically over the last 10 years. You still have big base mount pumps, other types, vertical inlines and that kind of stuff for your larger commercial systems. They do the exact same thing as these little circulators do. They are creating circulation to overcome the resistance through that large building. So that's the two of them, piping and circulation, definitely interrelated to each other, go hand in hand to move that heated water from our boiler to our terminal units. The optimal location for these 5 components is as follows. The terminal units go at the terminal spots. They go out where we need the heat. Could be the basement, could be the garage, could be the back of the shop, could be anything. The terminal units have to be out there. The boilers in the mechanical room, that's the component that is transferring and creating the heat to heat the terminal units. The other 3 components that we talked about, the expansion system, the piping, and the circulation, are there to deal with the common things that happen within a hydronic heating system. Expansion tank, like we talked about, an expansion system sits down here. Normally, it's at the hottest point of the boiler, leaving water temperature, because at that point, the air eliminator can do its best job. Hotter the water, the more air we get out of it. Also, if the air eliminator is on the intake side or the inlet side of the circulator, it's at the lowest pressure. So that again makes my bubbles as large as possible. But again, I have a whole separate video on that air eliminator. Circulators, again, all they're doing is moving the water from the boiler to the terminal units, through these other 3 components in the piping system to provide the heat that we paid for on one end to get it out on the other end to heat our building. There are 5 major components to a hydronic heating system: the terminal units, the boilers, the expansion system, the piping, and the circulator. All of them have to be sized correctly and in the correct positions so you can achieve maximum efficiency.